17. So sometimes I'm just going to ask you, do you understand what it should look like, what the function should look like, the graph of it, and what criteria needs to be met? What do I need to do to make that happen? So sketch the graph of a function with a degree of 2. What do we know about that? That's a quadratic, correct? And we know that it's going to be a parabola. It needs to have a positive leading coefficient. That tells us that this thing is going to go like this and has one x-intercept. It just crosses the x-axis once. This is on page 17. So I just need you to sketch it. I don't need anything fancy, okay? So you just go x and y. We want it to have a positive leading coefficient, and we only want it to touch the x-axis once. So you make a point there, and you tell me that the parabola is going to be pointing up from there. That is an acceptable graph. That's all you would have to do. Okay? You could have a variation of it if you'd like to. Let's say you're like, well, my parabola is going to be over here, and it's going to touch it once there, and it's going to open up that way. So either one is fine. It's a parabola. It just touches. It only has one x-intercept, and it goes up from there. So that's what I would expect you to do there. Next, it has a degree of 3, so that's a cubic. It goes from quadrant 2 to quadrant 4. Now you need to know your quadrants, right? Where's quadrant 2? 2 to 4, like it's going to go this way. So we're expecting it to do something like this. And it has 0 turns, 1 x-intercept. 0 turns, 1 x-intercept. So you make your sketch. It goes from here to here. 0 turns, just crosses it once. So we're just going to go like this. And we're just going to let our audience know that's where it is. 4. Right? I just want to give you variations because not everybody's going to look the same. You could have one that goes through the x-axis there. So it just does one of these. Okay? It just has to have a bit of a bend to it, and then you're good to go. That would work as well. Okay, so the emphasis is on or. This one, or that one, and anything in between works. You want a cubic that has 2 turns, 2 x-intercepts, sorry. 2 turns, and goes from quadrant 3 to 1. 3 is over here, 1 is over there. So we're expecting it to go from here to there. That's the end behavior. It has 2 turns. How will we make this happen? My suggestion is make sure you meet the criteria of 2 x-intercepts. So I'm going to make 1 here and 1 there. I'm just going to make 2 x-intercepts. Going to cross it there in those specific places. And it goes from 3 to 1. So I'm going to start here. I'm going to go up. I'm going to turn back down. And from there, just back up again. Does it have 2 turns? It has 1 here, and it has 1 there. Okay. Alternative. Again, I'm going to make my 2 x-intercepts there. Okay. I'm going to make it cross like this and touch there and then go back up. Okay. So as long as it has 2 turns and it has 2 x-intercepts, you're good to go. If it had 3 x-intercepts, we would want it to go back down right below the x-intercept and then back up, then you would get your third x-intercept that way. So you kind of have to just be creative with moving things around. Okay. Another one. I'm going to ask you to skip a few pages. I want you to go to page 21. I want you to learn how to match a graph to the proper equation. Okay? How about we go through this real quick? This one is a cubic function, right? We noticed by the shape. So is this one, cubic. What's this one? Quadratic. Quadratic, right? This would be x squared, x squared. This one is cubic as well. X cubed, right? The last one here. And this one is linear, it's just x, right? So right away you can kind of narrow out. So we just have one linear. Let's go and get that, take care of the linear one. F is a linear, so which one would we match it to? This one right here. This equation is linear. So we put F in there, okay? That one is taken care of. Now, let's do the quadratics next. There's two. What is my leading coefficient on this one? The leading coefficient will be positive or negative just by looking at this. It'll be positive because it's going up. The leading coefficient on this one is going to be negative. So you can kind of distinguish. You can look at the equation. One should have positive, one should be negative. So let's go and look at it. There's a quadratic here. And there's a quadratic right there. Right? So the one that has a negative leading coefficient, which is this one, will be matched with D. Right? D matches this equation, this quadratic. And the other quadratic here, therefore, is C. So that's taken care of. Now you've got the cubics to look at. Okay. What do we know about the leading coefficient here? Is it positive or negative? Think of a linear. If it had gone from here all the way to there, we would think of a positive, right? So leading coefficient is positive here. Over here, what is it? If you join the ends, this one is a negative. Okay, leading coefficient is negative here. Let's go down to the other cubic. This one, go from end to end, it tends to go up, right? So leading coefficient is positive. If it has no turns, this one has no turns. This is the classic no turns. So this one is E is gonna be matched up with the x cubed solo. Okay? It's just x cubed. It's the classic one, no turns. Which leaves me with these other cubic ones here. I'm looking to match this one. I'm looking for an equation that has a positive leading coefficient and is cubic, which is going to be this one right here. It has a positive, right? Leading coefficient is positive. So A gets matched up with that, and therefore B gets matched up with this one here because it has a negative leading coefficient and it has a bunch of turns. So whenever you have x squared or x, you are expecting a turn or two. Right? Well, there's either 0 or 2 turns. But if there's x squared and x, it's going to have a turn. Okay? If it's just x cubed, no turns. So you can actually write that down. If you ever just have the x cubed equation, it will have 0 terms. Okay. So that's how you match it. It's kind of thinking about what does the graph tell me, and how can I use what it's telling me to figure out which equation it goes with. Another thing that I didn't talk about here because we didn't need to, what is the y-intercept for this particular one here? It is 0, -2, correct? So the equation of this graph should have a positive leading coefficient, should have an x squared, and should have a constant term of -2. So let's go check that out. C, we picked C here. Is there a -2 at the end here? It is, right? So that's another thing to narrow it down even further if you have to. If you have to, right? That's all I wanted to say about that. I want you to try for tomorrow, pages 23 and 24. It's a matching scenario. So try page 23 to 24, matching. It's going to be tricky. There's a lot of options. But I still want you to go through it, okay? It's not going to be easy. It's not going to be easy, but it's going to really emphasize what you need to know in order to match. Maybe get rid of the ones that are slam dunks, right? Like, let's get those that we know for sure, get them out of the way. That is all for the matching. I think the only thing that I want to add yet is domain and range. This is kind of like a cheat sheet entry for domain and range. It's going to change once we do word problems. But go to page 22. And copy this down. For a linear, okay, the graph obviously goes like this or like this, okay. The domain is all real numbers. The range is all real numbers. So y belongs to the real numbers. That is set notation. I will write down set. If you want to use set notation, it comes from set theory, by the way, like chapter 3. And an interval is, the domain is -infinity to +infinity. The range is also -infinity to +infinity. That's linear. It's pretty straightforward. Okay. Quadratic. There you have to make a distinction. Okay. Okay, it goes like that or like that. The domain is also all real numbers because it just keeps on opening up indefinitely. For the range, you have to make a distinction. Okay, for the range, it's a little different. If it's pointing up, we write it a certain way. If it's pointing down, we write it a different way. Okay? I think I'm just going to give you an example here. Let's say the vertex here is 2, 5. let's say it's 3, oops, I gotta redo this one, sorry. Let's say this one is 3, -7. For the range, therefore, you would say that y, in this case, if it's pointing up, y is greater than or equal to 5. Right? 5 is the lowest, so you need your vertex for the range. There's no way around it. I need to zoom in. There you go. Okay? Or it goes from 5 all the way to infinity. If the curve is pointing down, leading coefficient is negative, we say that y is less than or equal to whatever the y value of the vertex is. In this case, it's -7. Or we would go from -infinity all the way up to -7 in this case. It's like the highest point you ever reach. So for range, you need the vertex. So make sure you write down need vertex for this one. And then the cubic is easy again, easier. Okay, it goes like this or like this. Your domain and your range are both anything goes. Y is part of the real numbers, X is part of the real numbers. We can also write it in interval notation. This is only true if there's no word problem associated with it. Okay? I'm going to write this at the top. Make sure you write this down as well. No word problems. Once we talk about word problems, it changes.